My name's Elena McHale, and I will be presenting on a spiral model of software development and enhancement that was written by Barry Boehm. So a little bit about Barry is at the time of writing this case, he worked for TRW Defense Systems Group. Currently, he's a professor of computer science at USC, and his background and interests revolve around industrial and systems engineering and astronautics. His H-index is 84. The journal that this article is written in is called Computer. It's volume 21, issue 5, and the pages range from 61 to 72. This was written in May 1988, or I should say published. There is 6,971 paper citations. So getting into the actual article, the research questions that I formulated that I thought this article was addressing was using a spiral model of software development, what enhancements are created and compared to past models of software development. Along with this question, we can also create some sub-questions. The ones I created were, how does the spiral model approach software development? What is it best suited for? And which conditions does it have difficulty with? So the motivations are the current difficulties with the past models before the spiral model of software development. The models in the past have proven to be either inefficient, time-consuming, or money-exhaustive for a range of different projects, and they seem to, have a certain project in mind for that model and not a wide range. The benefits to performing the research include the overall knowledge of the spiral model, the advantages and disadvantages to the model, and a pretty well-rounded example of the spiral model in play. So past models include the code and fix model, the stage-wise model, the waterfall model, the evolutionary development model, and the transform model. So starting with the code and fix model, this was the most basic of the models, which just starts with writing some code and then fixing that code later. This did have many difficulties. I think right off the bat you can tell that it's got very poor structured planning, so that creates the fixes to be very expensive, and there to be a number of fixes as well. And it also didn't really match to what the user's needs were at the end, so sometimes it was just outright rejected, which is a complete waste of money and time. And it was also expensive to fix, like I said, again, because of that poor preparation and testing. Next is the stage-wise model. So this was a software developed model in stages of the operational plan, operational specification, coding specifications, coding, parameter testing, assembly testing, shakedown, and system evaluation stages. Then the waterfall basically just refines the stage-wise model in two different enhancements. The first being that they recognize the feedback loops in between stages, and this allowed you to minimize the expensive rework of issues in the past. And the second was the incorporation of prototyping, which they found to be an extremely large part of this model. So one issue they had was with their primary emphasis on documentation. It seemed really unnecessary and almost in the wrong order. It was not really needed for an elaboration on an application that hasn't been implemented. It was also not working well for many classes of software, like interactive and user applications, for example. So the evolutionary development model was really dictated by adjustments based on experience, so based on what different users were saying on the development so far. The difficulties that it created, though, were the lack of planning. This almost went back to a model even before waterfall model, which had its issues. It also assumed that users just had flexible enough operation systems that it could adapt the unplanned evolution path that this model took, which just was not the case. It also created a hard-to-change code that was expensive when doing so and sometimes close to impossible. The final model was based on the assumption of the ability to automatically convert formal specifications into program satisfaction. So the difficulty with this is it's really only available for small products in limited areas like spreadsheets or limited computer science domains. It also assumed that the user's operating systems were flexible, just like the evolutionary development model, and it was difficult in tracking cost, performance, and features. So getting into the spiral model, something that's unique about it is it can accommodate models that were used in the past if they still fit for the specific situation. And it provides guidance for the best fit in the given situation as well. So one thing to note about just the overall look of the model is the radial dimension will track the cost incurred, while the angular dimension will represent the progress made in completing each cycle. Each cycle will typically begin with defining your objectives, some alternatives to implementing the product. So would a completely new product work better, to reuse an old product, or to rebuy? And then you'll also define your constraints that are imposed by the application. Next, you're going to evaluate the alternatives for objectives and constraints. So you'll identify different areas of uncertainty and different sources of that risk. Next, you will formulate the cost-effective strategy that will resolve the sources of risk. So this could involve things like prototyping, simulation, benchmarking, things of that nature. The next step would be determined by the relative remaining risks, which we will get into an example, so I'm not going to highlight all the different ways, especially since the case was most likely read by each of you watching this. So getting into the study is done on the TRW software productivity system, or the TRW SPS, which is an integrated software engineering environment. One thing to note is they decided to add a round zero just to determine the feasibility of the increasing software productivity and the cost that would be incurred with that. So let's start at round zero. The first thing that they looked for were the risk areas that were incurred. They wanted to see if the productivity gains were significant or not, and if it would really match with the TRW culture that was already in place at the time. They also started to plan for round one. So round one, the level of investment was definitely greater than round zero. The objectives and constraints were more specific, and additional constraints as expected were going to rise as well. They were also going to start planning for the next cycle, since that's what the entire cycle does. It basically plans while also currently executing the current spiral. Next, round two was basically about requirement specification. They wanted to provide a user-friendly front end, the operating system to be used in the workstations, and the functions necessary to support the host target operation. You can develop mini spirals for different issues that arise as well, which is kind of unique to other models, that they create their own spirals as they find issues that arise. And then they also address that risk that didn't match the user's needs or priorities at the end. One thing that's definitely beneficial to the study is what's on the right here. It's your template for a residual design. If you're anything like me, when you read this at the beginning, you almost kind of felt like you were missing something because it was so vague. But this kind of outlines how it's actually used. So getting into some features, advantages, and disadvantages of the spiral model. The features include development specifications that aren't formal, which can help with avoiding unnecessary risk elements. The next feature is incorporating prototypes as risk reduction instead of just unnecessary documentation. And then the last feature is accommodating the ability to rework and go back to earlier stages to eliminate risk even further. So getting into the advantages, it accommodates preparation for growth and change within the model evolution, which is unique to other models in the past. It'll provide a mechanism for incorporating quality into the software product development. It focuses on eliminating error in early stages at that, so you don't have to necessarily go back. Of course you can, but it's not necessary in most cases. So the next advantage is not having to overdo the analysis, planning, configuration management, and quality assurance testing. And then finally, it's a good framework for integrated hardware software system development. However, it does still have its disadvantages. Number one, it has a hard time matching contract software because contracts need accountability and control. The flexibility and freedom kind of has a difficult time adapting to what a contract will need. However, this has made some progress on adapting to that. The next is it's very people heavy and dependent in the risk assessment expertise area. You definitely need people that know what they're doing because it can almost provide a look that the project is heading towards progress, but it's actually headed for disaster. And then the final disadvantage is just a need for further elaboration. Experienced people have a pretty successful time with the spiral approach. However, if you are new to the field, there's not really any steps that are specified, and it's so flexible that it's hard to know what the next step is. So my conclusions based on this journal is because the spiral model is so risk-driven, it's very valuable for a number of different software situations and eliminating unnecessary spending or time. Since it's flexible and suited well for experienced people in the software field, it's pretty useful. However, there's a number of situations where there needs to be further work necessary for the model to be implemented by firms without their reservation. So I'm going to get into those now. So some further work that I thought was needed after this journal is to create a more detailed definition and guidelines for the spiral model. I did touch on that a bit when I talked about the disadvantages, so I won't get into that too much. And then I also feel like it needs to be adapted to include techniques of risk management. Because it is so people heavy, I do feel like there needs to be some reevaluation of the risk identification, analysis, and prioritization when it comes to the planning. So some ending remarks I have about this. I thought they did a very good job at defining what was necessary to get into the spiral model, as well as defining what the spiral model really is, while giving an example of a real-world application. I thought maybe a better layout for this journal, though, would be incorporating the example in with the explanation of the model. While I was reading, I did find myself almost thinking I was missing something because the model is so flexible. It almost came off as vague. So I thought that if they incorporated the example during their definition of the spiral model, it almost would have kind of came full circle and kind of explained how flexible that really was and how a business has decided to incorporate it. And then I liked how, even though the author did seem to support the spiral model, he still addressed the issues. I have read a number of journals that, were so supportive of the idea that they just couldn't seem to see that their article was biased in the end by not explaining issues with their ideas. So here's my reference. If you have any additional comments or questions, leave them below in the discussion.